Hello and welcome to the webinar from Valentin Software. Today, we would like to show you the system planning with 3D map import in PVSol Premium. My name is Sixten Fitko. I'm one of the hosts of today's show, and with me is my colleague Thomas Medeke. Hello, Thomas.
Good morning, Sixten. Hello and welcome to all participants. Thank you for your time and your interest in PVSol Premium. We will start with a short introduction about the content of today's webinar, and then we will change into the software to show you live how it works. Thank you.
Maybe at the beginning, a few words to our persons so that you know who's sitting here. Thomas and I, we have pretty much the same professional background. We both have studied meteorology here in Berlin. Then we worked for a long time together in the river environmental research business, followed by a short period in different environmental NGOs. And after a while, our paths crossed again, and now we are here at Valentin Software for since, I think, over 10 years. And here we are responsible for the technical support, for database things, and as you can see, for webinars and seminars and this kind of stuff. Okay, what will we show you today? And we will plan an on-grid system with electrical appliances and a battery system. During the planning, we will introduce MeteoSyn, which is the climate data selection tool. Of course, we will show how to define your demand by selecting a load profile or import a load profile. Then we will plan the PV system itself in the 3D environment here in our program based on Bing or Google Maps. It's a little bit more complex building. We will see how it will go. It's a little bit different to buildings that we have here in Germany, but it's quite interesting. Of course, we will show you the module coverage then and how you can configure the modules with an inverter. Then we will go back to the general planning, select the battery system, of course, show you how you can define your own tariffs, and finally the presentation. During the webinar, you have the possibility to ask some questions to us. Please use the chat function for that, which you can find on the right-hand side of your screen. We will try to answer as many questions as possible, but probably due to the time limit, it will not be possible to answer all the questions. We apologize for that in advance. Okay, I think that's it for the beginning, for the introduction. We now will change live into the program. So this is the starting screen you will get if you open the program. And I think Thomas will say a few words to the more general settings in the menu bar, and then we will start the real planning.
As you can see in the upper left-hand part, there's a menu bar here in dark blue. And under File, here you will find the typical options. You can start with a new project. You can open an existing project. You will have here a way to go to the last project you have worked on. Backup copies will be available. Example projects, a lot of example projects for the 3D part as well as for the 2D part. You can do project comparisons up to 4 or 6 projects. You can save the project as, and of course you can exit. Here in our databases, you can see the typical databases which are available for batteries, for battery systems, battery inverters, the main components, PV modules and inverters. And here also the tariffs are stored in databases. And here you can see the change log. After each database update, you can see how many new entries you have, how many battery systems, inverters, and PV modules. Maybe more interesting here is if we open the PV module database, you will have here a search field where you can enter the company you would like to use. In our case, we would like to use a module from the manufacturer LG. And if you click on the manufacturer, all corresponding or available module types will be listed here on the right-hand side. And here you have the opportunity or the option to select modules from this huge number of modules and to set it to a favorite list. We, for example, would like to use the LG380 N1C E6. And if I click on the star here in front of the module type, those will be automatically added to a favorite list. And that makes it more easy and faster to select modules during the real planning. And this can be done for modules, inverters, for tariffs, because you normally work with a hand of module types and a hand of inverters. And so you don't have to search through the whole database with more than maybe 17, 18,000 module types and 6,000 inverter types. Yeah, that's it for the databases. And yeah, now we come to the options. Here under user data, you can enter your company data, your company address and contact data, which will appear on the cover page of the presentation. You're also able to load the company logo, which is also available on the cover page and the project summary header. And if you go here in preview on the left-hand side to extend it, you are able to define the folder where your project should be stored. Another option which you can find here is that you can change between the unit system, SI unit, US unit, and SI unit with the American wire gauge. You can also change the currency symbol, which is adopted from the system settings, from the Windows system settings. And if you click this link, then you are on the system settings, and you can change from dollar to euro to South African rand, whatever you want. And in the lower part, this is if you would like to start with a fixed system type, for example, then you set a hook here and you can select the system type you're going to start with. Below, this is for the automatic update check. Once per day at the first program start, the program looks if a new release or a program version is available. This can be done, and also if backup copies should be made or not. Yeah, this can also be selected here. Yeah, I think that's it for the beginning, and yeah, you should start with a replanning. And to navigate here within the software, you have below of the menu bar, you will find an icon bar, and you just have click in the next icon, and the workflow is from the left, from the welcome page to the presentation. And as I've mentioned, you can just click into the next icon, or you can use the arrow bars on the upper left-hand side, or then backward. Yeah, and here we are on the project data.
So this is the first page where you can start the planning. It's more for the general data of the customer. So you can enter customer data, you can enter project data or a number of the project and so on. And you can enter the address, and if the address of the installation is the same like the address of the PV installation, you can just adopt it by this arrow. We already have entered it here. So this is the address of installation. The first important step of the planning, if you get some money for feed-in or anything else, or especially for the economics, is the start of operation date here. So we have set it to the 1st of January. We can give a project name, and you can also load the project image here. So you can see what we will plan in this project now. Okay, so let's go to the next window. This is the system type climate and grid window, and this is for the selection of the system type you want to plan. If you want to plan in 2D or 3D, and we have to select the climate data we want to use.
Yeah, and here we will find, if you click the drop down, the different options you have, the different types. This is a 3D grid connected PV system with full feed in. This is one with SHA Plus. With electrical appliances, and you can enhance the electrical appliances if you're using a battery system, electric vehicle, or a combination of both. There's also available a thermal system, a heat pump, or a heat rod, which can be taken into account. And there are standalone systems available with and without backup generator. And 16 has mentioned that we would like to use or to show how to plan a 3D grid connected system with electrical appliances and an additional battery system. Okay, and now the system layout change. As you can see here, modules, inverters, there's the meters, as well as a battery system and the load we have to define. In the part below, you have to select which type of design you would like to use. If you would like to use a 3D design or without 3D, then you have to check or uncheck the hook here, use 3D design. And below it, here you will find the part where you can select your climate data. You can use the both drop-down menus. On the left-hand side, the country, on the right-hand side, the corresponding locations. And close to the drop-down menus, here's a small globe icon. And if you click this globe icon, then MeteoSyn will be open. This is the climate data selection tool. And here within MeteoSyn, again, you will find different options to select your climate data. You will have a list view, where you have to select your country, and then all available climate data will be listed in the table. And if an internet connection is available, it's also possible to use the map to select or identify your location. Okay, now we have to change from Germany to South Africa. Here we are, South Africa, and we would like to, well, our building is close to Johannesburg and Alberton, and we can look if we will find the climate data for this location. As you can see, the location we have searched for is close to Johannesburg. If we zoom in, Alberton is below of Johannesburg, here in the southern part of Johannesburg. And as you can see, there's no climate data available for Alberton. And now we have to decide if you would like to use the one which is available, the closest one to Alberton, or if you would like to create your own climate data for the new location. We would like to create a new one. And therefore, we have to click the button on the lower left-hand side.
Then a new window will open, and it looks pretty much similar to the one before. We can select the country, then we can search here for the location, for latitude, longitude, and the zip code again. So now we use the search for location name. We start, and it gives us several locations here in Alberton. So then we see the red marks, and we click on the mark. We want to use, then the name is adapted into the location field here on the left-hand side. And we could add the state, the zip code again. And now we have to choose which source we want to use for our climate data. There are different sources available, as you can see here. One is Meteonorm 8. Then we are using climate data from the company Meteotest, they have their own software, which is called Meteonorm, and we just use it. Then there's another source, which is called PVGIS. I think it's a short source funded by the European Union, I think. And we have Solcast, which also can be used, but here you can just create 2 records per month for free. And if you want to create more records, then you have to pay for it. But if you're already a member of Solcast, then you can use your account for that. It's also possible. Finally, we have measurement data. So if you have your own measurements, for example, then you could use this one, and the window slightly changes here a little bit. And then we could or should enter data source, of course, so that you remember where the data are coming from. Then the measurement period, of course, and in a small table, you would have to enter the monthly values. There are different units available here for that, and you just click in the fields and enter everything. And if you have also the temperature available, then you can also use this different units. If you don't have the temperatures, then they are automatically interpolated from the existing data records. Okay, we are using Meteonorm, so we go back to that. Then we just press OK. Then the new record will be created. It will stay in your database, so you can also use it for future projects, for example. So then we press OK, and now it's adapted into our planning, as we can see here. Okay. So I think that's it for the system type, climate, and grid. We can move on to the consumption window. So this is for the definition of your demand you have. Now, there are different options available. You can just click on add consumption, and then we have here the different options. We can import a load profile. So this is called load profile from measurement or measured values. There are some pre-imported available. They are basically coming, or mainly coming from the German power companies, of course. So that's a source that's mostly available for us. And you can just click on it and then override the annual energy requirement, and then it's distributed according to the profile you are using. Second option is, if you go more down here, is the load profiles from day profiles. So they are a little bit different here. So you can click on these, and they are so-called normalized profiles. That means, as you can see in the small table, there are only percentages in this profile. And if you enter an annual energy requirement, then this annual energy requirement is distributed to the percentages over or through the whole year, down to hourly values. So first, monthly values are used. So, for example, if you have 10% let's take a look here. If you have now about 8% here for January, then from the 1,000 kilowatt hours, then it's 8 kilowatt hours. 80 kilowatt hours are used in January. And then we go to the daily profiles, and then it's distributed all to the days, to the hours. First, we divide the 80 kilowatt hours by 31 because we have 31 days, and then it's distributed according to this percentages to the hours. So this one can also be copied, and then you can edit it. For example, you select one and right-click, copy, and then if you click on copy, then a new window will open. Then you could overwrite the values here if you want to adjust it a little bit to your requirements, for example. So you can give it a new name, then you can enter or click in the table here for the percentages, and then you can enter percentages, or you can also enter the kilowatt hours you are using for your specific hour. And afterwards, after you have entered the whole kilowatt hours, then you click on normalize, and then it's converted into percentages. Okay, after clicking OK, you then save it, of course. So then we have the third option. This is for individual appliances. It's down here. This is more or less if you have really small scale homes, I would say, and with only a few appliances you want to use, and this can be defined for example bulbs or a fridge or whatever. So but it makes no sense if you have a lot of appliances, then it's much more complicated, and then it would be easier to use one of the load profiles. Okay, I think that's it for the general thing. So we want to import the load profile here. So if you have one from your power company, then you can also import it. And so we click here on this. Then a new window will open. You can give it a name. You can comment or where it's coming from, and so on. And then we have to define the time interval from 1 to 60 minutes. A lot of options are available. The number of days, in our case, it's 365 days. But if you have only 1 week, then you can also use this week. And then the software automatically interpolates this 1 week through the whole year, so that you have a full profile for the whole year. Okay. And then the starting date of the profile, in our case, it's the 1st of January, and it's coming from 2021. We have to define the units, which units are in the profile, which we want to import, if it's kilowatt, watt, kilowatt hours, or watt hours. In our case, it's watt. And yeah, this is basically to select if the decimal sign is a comma or a point. In our case, it's a comma. And 1 value per line. I don't know how the profiles in your country are, but this is, in our case, we have 1 value per line, but in the UK, for example, you have 1 day per line. This can also be imported. Okay. Then finally, we have to select our profile. So desktop here. Here we are. Click on it, and then if we click OK, and if everything was defined in the right way, then the data import is successful. Maybe one remark for the load profile. So it has to be, or normally you get a load profile with a lot of information in it. There's the header, there are the dates, the hours, minutes, whatever. You have to remove everything of this, and we need just 1 column, and that's the column with the load data, as you can see here. So remove the header, remove the dates, etc. And we just need the load. And that's why you have to define the minutes, what is the time interval, and how many days you have, and this gives you a certain number which is shown during the import, and this number should be the same like the rows you have in your profile. Okay, so that's our load profile here. So then we click on OK, and now we have it in our planning, and that's it for this window. We have defined the consumption we have during the year, and now we come to the planning of the real PV system. So we change to 3D design, click on Edit, and then the 3D visualization will be open.
Yeah, and here you have to select the couple of objects you would like to use, and again, you have different options available. In a few seconds, we will start with the map section, but the additional options are an imported 3D model. If you have one available in the supported file format, you can use predefined buildings with a simple roof area, rectangular or trapezoidal. You can also use more complex building with different roof types, with flat roof, pitch roof, tented roof, hipped roof. Also, high-rise building would be possible. You can cover the facade as well as the attic story. You can cover walls, and also open areas are available, flat open areas and tilted open areas up to 60 degrees. Yeah, we would like to use the map section. And to start with, you just have to click here in a small map here on the upper right-hand side, and it will be focused on the address you have entered on the project data for your installation. And here we are. Yeah, now we have to zoom out a little bit to identify our object. This is the one we would like to use, and can drag and drop it here more in the center. And here on the upper right-hand side, you have the different map providers like Google and Bing Maps, and these are regional map providers for Austria as well as for Germany. And if I remember right, we would like to use the Google satellite, as we have here, and then we zoom in as far as possible. This is the one we would like to plan here, the building. Yeah, then we have to click on select here on the upper or the lower right-hand side, select. And then the orientation of our map as well as the scale, the pixel per meter for our map will be automatically detected and adopted. And if we then click on start, we are within the 3D visualization. Yeah, and we can start with our planning here on top of our open area on our map section.
Maybe we should also mention that you can, of course, use your own pictures. For example, if you have a drone and you make a drone flight and you set the drone over the building, take a picture, and then you can use that. The difference is that you then have to scale it.
Yes.
But this can also be done in the software. Okay. So maybe we should say a few words here also to the building. It's a little bit more complex than that we usually have here in Germany. There are 3 building parts. It's kind of an L shape, and so it cannot be created with just one building. So we have to create it with 3 different buildings. And therefore we are using the polygon tool here in the map section.
Yeah, and first, to have a clear view, I would like to hide here the terrain grid, and this is possible here close to the camera icon on the left. There's a small tool, and if you click this tool, here we are able to uncheck the grid terrain. Okay, now we have a free view to our building. Yeah, this is the building we would like to create. As Sixten has mentioned, we will start with this one here. It's a building with hipped roof, and therefore we are using the polygon tool. And this means we have to sketch the outline of the building as well as the ridge. Yeah, and then you can extrude the building, you give him a height, and yeah, let's start. Just click corner here. Also here. Then you have to press the enter button, and you can define the ridge of the building. It seems to be to this point here, and if this is done, to interrupt the drawing mode, you have to press the escape button. And here we are. Now we can adjust it a little bit. That's parallel to the edges of the buildings, depending on your map here. And if this is done, we can make it the right angle via right click. I'll make it the right angle, and afterwards again do a right click, extrude a 3D object, and yeah, then the program detects automatically that we will have a building with hip roof, because the ridge is not from this end to the other one here. It's a little bit shorter than the edges here. Yeah, then we can edit it a little bit here. We can enter the height of the eave. It should be 3 meters. And we can also define the roof pitch, which should be 25 degrees. Yeah, now the building is ready, and yeah, now we have to move it a little bit away, to draw the next polygon. Move it here to the left-hand part, and we can delete or remove this part here of polygon, that we have a free view to our map to draw the next polygon. Okay, I would like to start here in the lower right-hand edge. It's up to here. Then we have to go to the corner upper left, and then we have to move down to this part. Again, please press the enter button, and now we have to draw the ridge of this building. No, maybe it's to here. Okay, then to interrupt the drawing mode, press escape. We can adjust it a little bit. It's here, more or less a rectangle.
As you can see, you have to guess a little bit in some for some edges where the edges are probably where the edges probably are, because we move the buildings into each other. So that's how you can create this kind of building types.
Okay, then I make it the right angle. And now we have to draw the polygon of the third building. Again, a small rectangular here. Starting point. So on the upper right-hand side. Up, yeah.
So now we have to guess a little bit, of course, here.
Tree.
Of course, it would be much more easier if you have all the measurements. Then you can just create the buildings and then put it into each other. But if you only have the map view and maybe you want to use it for short first guess or quick fix guess, then you can use here this map view. Yeah.
Okay, now we adjust it a little bit here.
It can be a little bit tricky sometimes.
That depends also from the quality of the map, of course. If you have here sharp edges or not. Okay.
Then you can zoom more in and then you can see it, of course, a little bit more.
Okay, now we have our two polygons here for the building. To make it the right angle here. And then we have to move one of the polygons away. Click, click. And then we can extrude the second building. Extrude 3D object. Again, it's a building with hipped roof. We need to enter the height of the eave as well as the roof pitch. I have to confirm it's okay. The second building is ready now. So we move building 2 away. And now we have to place our third polygon again. Yeah, we have to bring it in position. Then we have to remove the second one here. Remove. Also the ridge, remove. And then we can extrude building number 3. It's also a hip roof with 3 meter height for the eave and 25 degree. Okay, now we have to bring all buildings together to our example here. Means we have to deactivate the collision. Okay, and when we can shift it into each other here. And we have to do the same.
Maybe you can show if we don't deactivate the collision, then you can move it into each other. Then, in this case, yes. I'm surprised.
This one is deactivated. But in the upper part, it's not possible, as you can see here. Yeah, it's not possible to move it into each other. But because here we have deactivated, it would be also possible for this building here.
Right.
Okay. Yeah, then we have here further shading objects like trees. And also for the trees, we can use the polygon tool here. Just click on it, and then we have to draw here a circle. Do a right mouse click on it. Extrude 3D object, and it will be detected as tree or as smokestack or conifer. In our case, it's a deciduous tree. Okay. And the height should be 12 meters. Okay. We can bring it in the position here. And to create the other trees, of course, the easiest way would be that we do a copy here. Make multiple copies, and then we have here the clipboard, and from within the clipboard via drag and drop you can place as many trees as you want. Another tree would be maybe here. Here's the third one, fourth one. There's also one, another tree, and 2 further trees here on this side of the building. Yeah, and if you have defined or created all trees, then you can close the clipboard, and here we are. Now we can activate the building. and then it will be focus on the roof part you would like to cover. And yeah, now we have to change to the module coverage, and yeah, can place modules here on the roof.
Yeah, that's right. So there are, first of all, we have to select our module we want to use here. We can click here on new module, then the database will open, and yeah, we can show the full list first so that you can see the difference why we have selected the favorites here. Yeah, this is the whole list of companies here, and if you go to the other drop down, then we have the corresponding modules here. And yeah, to minimize the search here, then we can click here on select from favorites. Then only the favorites we have defined are shown. First the companies, and then only the corresponding module type here. And then we could select it. But it's also possible to go into the large database here, so they call it in the detailed selection. If you click on that, then the full database will open, and so you could also define here your favorites, for example. Now, as you can see, favorites is also selected here, and we only have our favorite company with the favorite module here. But you can, if we remove the hook here for the favorites, and we can see the full database again. Okay, so you can also select from this database here. Maybe. So we select our favorite now. Click on select, and then press on OK. And then we have different options to place modules here on the roof. First one is for just drag and drop the single module, and then we can drag and drop each by each. If it's red, you cannot place it, then you're on the wrong area. If it's green, then you can drop it because you are on the area you are currently focusing on. Okay, then we have the cover option here, which means we cover the whole roof. But in this case, because we have moved buildings into each other, so if we would use this option, then it would really cover all the roof area, and also cover the area under or inside the other building. So what we select here is the fill area option. Press OK. You can enter horizontal and vertical dimensions for it, and then we just draw a frame here by right-clicking our mouse key, and then we have some modules here. One of the main advantages of the 3D planning is the really detailed shading analysis. And the first step or first impression of the shading situation on the roof is the shade frequency distribution, which we can calculate here by clicking on this icon. And now we can see some percentages, and these percentages represent the reduction of the direct irradiation over the whole year. So it doesn't mean that you have 6.3% yield reduction, for example, because this also depends on the configuration and inverter you select, and how's the MPP tracking of the inverter, etc. It means that the irradiation reduction over the whole year, but it gives you as I told you, an impression on how is the shading situation, and if you have to decide which modules should be in one string because they are or more shaded like the other ones, or there are some that are not shaded at all, then you would put all the shaded modules in one string to one MPP tracker, and the modules which have no shade on it then would put in another string on an MPP tracker, so that they don't influence each other. So this gives you the hint which probably should be in one string or also removed. Of course. In principle, I would say this percentage are not really critical. It's more critical if you have maybe 20% or something like that. But in this case, we would remove the lower modules because we don't need that much modules here. Yeah, the demand is not that high, and in South Africa we have a high irradiation, and the rest of the modules principally produce enough energy for our system. But it's of course up to you.
Energy we fed into the grid is too high.
That's right.
Be used by your own. In this case.
Right. But at least it's your decision. If you have enough money, of course, and it's okay for you to feed some energy into the grid, and you are good paid for it, and then it makes probably sense to use more modules. But yeah, I think not in this case. Okay, I think that's it for the module coverage here. We can.
Then we come to module configuration.
Module configuration, right? And here we have to search for a suitable inverter.
Yes, and there are again different options available. This is to configure modules only from the shown mounting surface. We only have one module area because we have to select the first option here. If you have modules on different roof parts, northwest and southeast, for example, then you can combine them here and configure it together. And if you have a lot of module areas which are orientated to the same direction and have also the same inclination, then it would be possible to merge them to one huge module area. Therefore is the third icon here. We use the first one. We have only one module area. It's a module area northeast. And now we have to look for a suitable inverter. You can ask a software for suggestion, a recommendation of configuration, and therefore it makes sense to limit down the huge number of inverter. And here's a small link, inverter selection. And if you click on it, here we are. Again, we have all manufacturers here on the left-hand side, and in our case now SMA is pre-selected, and now you have to decide which inverters from SMA you would like to use, and therefore you have to set a hook here in these checkboxes, and then it will be used to find a suitable inverter. And this can be done automatically via these two icons here, with one with a green circle and white cross. You can select all suitable, and with the one right or next to it on the right-hand side, you can deselect all inverter types, and again select all. And now from the selected inverters, the best configuration will be search for. Select. Now we have a pre-selection of 60 inverters, and 29 of them are suitable. And if you click this small button here with the arrow down, then you will get automatically a suggestion of your configuration. Another option would be to calculate all possible configurations. This is here under the button Select Configuration, calculate. Then again, we have the 60 pre-selected inverters, from which 29 are suitable. And if I now click on Start, we will get all possible configurations. And in our case, we have 25 possible. The one which is here on the first place here, this is the one which is recommended, or that's suggested by the software. But we would like to use the second one because we would like to add a battery system, and therefore it's this inverters is needed. And if I click on OK, it's the same configuration. We have two MPP trackers, and for each MPP tracker you have one string with 7 modules in series. Here you can see The design range, it is possible from 5 modules in series up to 13 modules in series. And yeah, all this will be checked. If we, for example, change here to 4 modules, then we get automatically here a red cross, which means you have to check the system, and you will get a hint on a lower left-hand part of the window that yeah, of course, the number of modules we have placed on a roof is 14, but we have only configured 11. And the other reason for the red cross is that the minimum MPP voltage of the inverter is not reached. And this can be also seen if we click on it, on this red cross, then we can see that we are outside of the lower limits, the lower edge of the MPP voltage. Okay, now we can change it back to 7. Can confirm it's okay. And here we are. This is our configuration. 2 strings, string 1, MPP tracker 1, string 1, module 1, or inverter 1, MPP tracker 1, string 1, and module 1 up to 7. And this is inverter 1, MPP tracker 2, module, string 1, and module 1. Yeah, I think that's it for the module configuration. Do we have any questions, Sixten?
No,
No, it's up to now. Okay. Yes, and I think we should adopt the data. Yeah, leave the 3D.
I think we should.
No, yeah, we wanted to do a
screenshot first.
Screenshot. Yes. Yes. Okay, then we can go back here to the terrain view to have an overview to our system. As you can see here, and then you can change the view. These are the different view options you have, and yeah, then it's possible to do a screenshot or more, or different, or several screenshot of it. And therefore, I have to click here the small camera icon, and then the shutter release button. And then a screenshot of this view here is done. And yeah, via right mouse click on this screenshot, you can use it or can define it as overview picture. And this is the picture which will be placed on the cover sheet of the presentation. You can also give it a name if you want. Now it's marked as an overview picture. And if you know adopt the data, should this be adopted? Yes. And we would like to do the calculation of the shading ratios, and we'll do a shade and the yield simulation. Okay. Yeah.
So this is now the time where the real shading simulation takes place. So where the software looks how is the shading at the different at the different times. So how is there shading on a module? Has to be set a bypass diode of the modules if only parts of the modules are shaded. How this will influence the characteristics of the modules, the voltages, etc., and how a shaded module influences the other modules in the string, the MPP tracking of the inverter, etc. So all this is done in this small simulation here before we do the final simulation. Of course, it could take much more time if you have a really large system with a lot of shading objects, and it's probably a mounting system, etc. And then you can sometimes sit an hour or something like that. But in this case, it was very quick. Okay, so that's it for the planning of the real PV system. We can go now to the next step, and this is for the battery systems here. So in principle, the selection is very easy. We have this small drop-down menus. You have to decide for a manufacturer. And in our case, we have used SMA for the inverters, so we also use SMA here for the battery system. And we use Sunny Island with an LG Chem battery here. In this case, we select the 5.0 kilowatt hours. In principle, the battery system consists on consists of two parts, and one is the battery inverter or charger. If it's on the DC side. So in our case, we have AC coupling here. Then we could also have DC coupling on the if you connect it directly to an inverter, an hybrid inverter or something like that, then it's coupled on the intermediate circuit on the DC side of the inverter. And then the third option is DC generator coupling, if you place the system directly to or connected directly to a module string. Then we have the nominal output, charging powers and discharge power of the battery inverter or charger. And this is all for the inverters, or the battery inverter or charging unit. And the second part is, of course, the batteries itself, as you can see here. In our case, it's an LG Chem, and the batteries are stored, of course, also in the database. In the lower part, you can see there are two bars which give you some hints about the sizing of the battery system. First is for the charging or discharge power. So because, as you can see, there are some marks here. So load peak, for example, in our case, the load peak is 2.9 kilowatt. It's coming from our defined consumption. So at a certain or some certain times during the whole year, we could have a peak load of 2.9 kilowatt. And of course, it would make sense if our battery system can then cover this peak load if necessary. And so we should be above or close to this load peak. In our case, we have 3.6 kilowatts, so we are above this 2.9, and it should be okay. In the lower part, we can see some hints to the battery size itself. So the kilowatt hour the battery can store. There's it's called recommendation HTW. So HTW is a university here in Berlin. And we worked together with them, and we developed a small calculator which calculates some hint to the size of the batteries by using the defined consumption and the size of the defined battery system. And here we have 7 kilowatt hours. We are below it, but if you simulate it, we will see that it would be enough, and enough for our system here. And it would make no sense to have a larger system. But maybe I should say a few words how the simulation in PV Sol works in principle with the battery systems. For every simulation step, the software looks how is the demand, of course, so the defined demand, and then what is produced by the PV system itself. Then first, if enough energy from the PV system is available, then it's used directly to cover the consumption. If you have more PV energy than demand, then the software can charge the batteries. If they are full, then the rest will be fed into the grid. If you have less energy from the PV field than demand, then the software looks if there's energy from the battery is available. And if there's energy in the battery, then it's taken from the battery. And if then additional energy is needed to cover the consumption, then it's taken from the grid. And you cannot change this simulation. For example, if you would like to have would like to define certain times where the batteries should be loaded or used primarily, this is not possible. Yeah, it's always, yeah, first, can you cover it with the energy directly from the field and from the battery, etc. Yeah. So that's the way how it works here in PV solar. Okay, I think that's it for the battery systems. We can move to the cables here. This is, well, basically to define the cable losses. You can enter total loss if you know, okay, this kind of system has about 2%, whatever, or you can enter it in detail, which means you have to enter the cable length and cable cross sections, and then the software calculates the possible cable losses.
Yes, and an additional option is that you can add circuit devices, your security devices to your plan here. And yeah, there's one special point, and this is the point A here, where it goes to the consumer, and you can decide if you would have your safety devices in front of this cross point here or behind. Another option is that you can decide if you would like to have a feed-in meter. Yeah, then in case of a bidirectional feed-in meter, sometimes you don't need it. And this can be switched off here, by set the hook feed-in meter, and then it will be deleted or removed. And then we have different parts. If you would like to have your security devices or circuit devices in front of the consumer, then you can add it here in the upper part at the circuit symbol. Here are different symbols available, circuit breaker, and if you go down, fuses and conductors. Then to add it, you have to press here the button, and then automatically it will be added here in the list and also added here into your cable plan. It's the same if you would like to have the symbols after the load, then you have to add it here in the lower part. And if you come to the cables, we have the AC cables, which means that from the inverter to the meter. Here you have to enter the length. Here you need to enter the one-way length for the inverter cable here, for the AC cable. In our case, it should be 10 meters. Then you can also decide about the cross section of your cable. As bigger the cable, as less losses you will have. And it's the same with the material, copper and aluminium. If you need copper, you have less losses as if you need the material aluminium. Okay, and then it will be adopted immediately here. We have entered 10 meters, 4 millimeters square. And if we scroll down, here for the green part, for example, here you have to define the length of the string cables. And here you need to enter the go and return lengths because of the minus and plus. Okay, and in this case, it should be 15 meters. And we also use 4 millimeters square and copper. And this have to be done for 2 strings. As you can see, we have 2 strings here. First string is defined, and one option would be to change here from string 1 to string 2. Another option would be apply values for all MPP triggers, then also trigger 2, where we have 50 meters and 4 millimeters square. And here on the upper right or lower right hand side, you can see which are the total losses due to our cables. It's around 0.8%. It's around 40 watt. That's it for the cable and cable losses. Now we move on to the plans and to the parts list.
This is of course depend on the system we have created. There's not much we can do. We cannot change it. It includes the modules or strings we have, the inverters, batteries, and so on. We just can export it here. This one in a PDF, PNG, or SVG, which is a vector graphics format, and then you could import it into a CAD program if you want to add something or change something here. Under options, you can just add the legend and can tell the program where should the legend be. There's some more drawing space here for some more information about company, etc. And you can decide if it should be landscape or portrait, or if it should be in the legend, in which color should be the legend, or if the circuit diagram should be colored or not. Okay. What else do we have here? We have an overview plan of the whole system. So all the things we have drawn here. Then maybe the string plan is more interesting. So that you can give to your constructor or whatever, installers, and that they know how they should connect the strings, of course. Then we have a kind of a parts list. It also depend on the selected components, like modules and inverters, etc. You can add your own items here, but if you click here on new item, then for example, I don't know, mounting system or whatever, or some other materials. Then you can also give everything an item number here. If you click on this atom, and the software also remember this item number. For example, if you select the modules, the LG modules in a future planning, then the software automatically takes this item number from a list, and you don't have to enter it again. Enter in the manufacturer, a name for it. What else? Then we see here some hooks for visible here, and here you can decide if this items should be shown in the presentation or not. For example, if you plan a system here with an electric vehicle, then it sometimes makes no sense if the vehicle appears in the parts list, because it's not really part of the PV system, and then you can remove the hook, and then it isn't shown in the presentation. Okay, I think that's it for this list here, and we can come to the financial analysis. And here we have, of course, to define the costs of the system, and then we probably have also some income.
To enter the costs, we have to press the edit button here on the upper left-hand side. New window appears with the economic efficiency calculation. And we are on a window of general parameters where you have to enter the assessment period. In our case, we have 25 years. You also have to define the annual average return on capital employed, which means the value of the loss of the money due to inflation. It's set to 0. And below, value added sales tax, all entries are gross, so all entries are net. This is, if you remember, if you open your planning in 1 month, 2 months, or half a year, that I've entered all as gross or all as net. If you do a changing here, it will be not added tax automatically to the number, to the values you have entered. Then we have to move on to income and expenditure here on the tree view on the left-hand side. You can also use the continue button or lower part here. And here we have to enter the total cost of your system, or the specific cost. You can enter it as a specific cost, South American rand per kilowatt peak. You can enter the absolute price. It is also possible to enter the cost in detail. Here we are able to add several positions, maybe investment for PV modules, inverters, under construction, and so on. All this would be possible to enter here. Okay, we go back here, uncheck these. Okay, and our total cost should be 235,000. And you can also take into account if you get subsidies, you have to enter your annual operating costs. In our case, we have 1,000 South African rand per year. You can take into account an inflation for this. If you have other costs for insurance or whatever, it can also be entered here. Also, if you have other income or saving, all this can be entered here. You can take into account financing. Up to 3 loans in parallel are possible. And you can also take into account tax and depreciation. But yeah, therefore, we have no information how it works in South Africa. And yeah, we recommend to ask a tax consultant for this, for all things with taxes and depreciation. Okay, now we have defined the course. Where we are. Okay, here we are. We have entered the cost and the assessment period. And yeah, now we have to look if we get some income.
Right. First of all, we have to define the concept here. There are two concepts available. One is surplus feed-in, which means we first use the PV energy to cover our consumption, and if there's something left, then it will be fed into the grid. Another system is called net metering. This is your PV system produces energy, and everything is fed into the grid, and then normally you can take the same amount from the grid, sometimes free of charge, and sometimes you have to pay a lesser price then, and so on. That's it's common, for example, in the Netherlands, in Europe, or Poland.
Poland, Denmark.
In our case, it's surplus feed-in here. Okay, and then we have two possible two possibilities of income. One is a feed-in tariff, and the other one is we save some money because we don't have to take it from the grid, so the energy. Okay, first, if we have a feed-in tariff, then we have to select it or already define it. So we click on Add here. In our case, we have to define it. So we click here on New. Then we can select the country, South Africa. And it's Johannesburg for the city. But if you don't enter anything there, it's also okay. You can give it a name. It's a COJ business in our case. And what's in the lower here? That's more important here. It's when it's valid from. So type and how long is the payout duration? Okay, so 25 years. Of course, the most important thing is how much money you get. And this is the tariff. It's 0.48. Here you can, if you have more, I think steps or tariff steps or tariff bands, then you could enter here some more by adding a line here. You can see this green. You can add a row if you click on it, and then you could add. Okay, it's from if I have a larger PV system, then I get another amount of money of money. Here in this case, we have power in kilowatt peak. In this case, it depends on the size of the system, but you can also change it to kilowatt hours. So depending if the price depends on the kilowatt hour you feed into the grid, then you can use this one here. Okay. So I think, that's it. We press OK. So our tariff is defined, and to adopt it into our planning, we have to select it here. So then we can also enter an inflation rate for it. I think 6%. Yeah. And in the lower part, then we have to define our from grid tariff. So the price we have normally to pay for our energy, which we take from the grid and which we will save because we produce our own energy. So again, we have to create a new tariff here. It's of course it's similar to the feed-in tariff here. South Africa, Johannesburg, I think. Whatever. You can also create your own energy supplier. If you click here on this small icon, create again new, and then we have to enter the name, City Power. You could enter a website, etc. It's not necessary, and then save it. Then it's available here in the list. And then select it, and then it's a new tariff. You give it a new name. Business prepaid.
Business prepaid.
Yeah. Then in the lower part, yeah, we can residential or corporation, but doesn't matter. It's just for informational reasons. If you have a minimum quantity which you have to take from the company, then you can enter it here. And then there's a base price for example, for the meter or whatever you have to pay. You can enter it here, but it's also only for informational reason, because you have to normally you have to pay it anyway, so you don't save it. So then we have to define the tariff here. Yeah. Now we have different tariff bands available here. So it's depending on the energy in kilowatt hours. For one, we get 2.43910. And if we have 1,100 kilowatt hour, then we would pay 2.55500. Okay. Then we select it. Then we can enter an inflation rate here. And now we have done our first planning, so we can take a look at the results. Now it simulates everything.
And here we are. Now we're on the results page, on the overview. And here on the upper right-hand side, you can see the PV generator energy we have produced. It's 10,185. The specific annual yield is close to 1900 kilowatt hours per kilowatt peak. We have a performance ratio of higher than 80%. And on the left-hand side, these are the main information about the financial analysis, the internal rate of return, the revenue or savings, as well as the accrued cash flow balance. And here we have different graphs available. This is the production forecast with consumption. Above of the zero line, we have what comes into the system, and below of the zero line, there is which goes out. And of course, we have the PV generator power. We also have the battery for covering the consumption, and we have the energy from the grid. And all this energy is used to cover the consumption, of course, to charge a battery, and a little bit of the energy we have to feed into the grid because it can't used. There are further options how the PV energy is used. For each of the months here, you can see the different bars. It's used for the direct own use, for the grid feed in, as well as for the battery charge. And there's another graph available how the consumption is covered. Here in gray, this is the consumption, and mostly it's covered from the PV power, directly from the PV power, as well as from the battery, and only a small part is covered from the grid, as you can see. This is here's the light blue color in the bars. And then we can have a closer view to the simulation results here in the tree view under simulation. Again, on the upper part, this is our PV system, PV generator output, the specific yield again, and the PV generator power. The direct own use is more than 6,000 kilowatt hours per year. For the battery charge, we can use around 900 kilowatt hours, and 3,200 kilowatt hours around we have to feed into the grid. And so we come to our own power consumption of more than 68%. And then we can have a look to the appliances. This is the appliances, the demand we have. It's 7,042 kilowatt hours per year, which we have from our load profile. And 6,067 from this demand we can cover by the PV power, 722 by the battery, and only 260 kilowatt hours per year by the grid. That means we have a solar fraction of more than 96%, which is really good. On the lower part, this is some more information about the battery. We have used 904 kilowatt hours to charge the battery, but we have losses inside the battery, of course, and losses due to charging and discharging, so that we can use to covering the consumption, we can only use 726 kilowatt hours. And our cycle load is 3.8%.
Cycle load means that are the cycles of the battery system which are used for the whole year.
The discharging and then charging.
It's calculated based on the number of maximum cycles the battery has. But this is stored in the data record of the battery system or of the battery itself. And
from this, the service life can be calculated.
Right. Okay, what else do we have? We have, if you want to have a really close look to the results, then you can use the diagram editor here. If you click on it, then you could select all the simulation results, all the things you have defined. For example, consumption, etc. Just select one here. Can press OK, and then you can. This is a daily view. You can see the weekly results, monthly results, or for the whole year. And this one can also be copied. You can copy the graph itself, or if you want to have the numbers, then you could copy the table to clipboard, and then you can open Excel or whatever and paste it into it, and then you have all the numbers. Then we have different other graphs here. Use of PV energy.
The one we had.
This one, Okay, then the system energy balance, which gives you an overview about the gains and losses in the system. Of course, you have the irradiation. It's a big gain. Then we have some gains due to reflection, the orientation and inclination, and the rest are all losses, efficiency losses. So the efficiency of the module, efficiency of the inverter, shading losses, etc., etc., etc. But this gives you for example, if you have the feeling that something goes wrong because your results are very bad, you have only a low amount of energy which is produced, and you can take a look at it here, and it can see where are the big losses, and then sometimes you can see, okay, there's a large loss, for example, for the MPP matching, which basically means that you are often outside the MPP tracking range of the inverter, and then you have to adjust, probably use another inverter or decrease the number of modules in a string, for example. So normally, if you get this or use a suggestion, this will never really happen, so you never will have large numbers there. But if you define it yourself, and of course, you get the hints that something could be wrong. But if you do it anyway and simulate it anyway, then you can see, okay, I have large losses, for example. Okay, then we have the financial analysis based on our entered numbers here. This is the internal rate of return here, about 30.5%. Then the amortization period is about a little bit over 9 years here. And this is the payment. So the feed-in that we get, and that are saved. So we don't have to pay it to the power company. We can have these results for all the years here in the cash flow table. And there's also cash balance graph. Okay, I think that's it for the results window. We can now show the presentation. So that's the type of thing you can give to your customer or your client. That's a starting page with all the information from the beginning, project data, etc. here, and then we have all the overview, what is used, whereas the climate location, how the system looks like, then the results here, and all the things. We have of course seen here in the results window. Some pictures, horizon line, etc. Okay, you can decide what should be in the report here by clicking on further options. There's a long list of all the things which are in the presentation, and if you set the hook, then they are in. If you remove the hook, then it's out. There are also alternative languages available compared to the program languages here. Chinese, for example, or Europe, Polski, or whatever. Okay. The presentation can be printed out. You can say export it to a Word file or a PDF file. Well, I think that's it for full planning here. And we can move to another project, right?
Okay.
Okay, so oops. It's gone now. Do you open it, or do you have closed it, or?
It's gone, yeah.
You're right. Yeah. I cannot see the program at the moment.
Okay. And is it back now?
No.
Oh, okay.
It's just a PowerPoint presentation. Which can you see?
Okay. Is it back now?
Yeah. Now we can see the program.
I had to close and to open the new one, and maybe this was the reason, because it was gone. But now it's back.
Yeah, no, it's back. Okay. But don't worry, we don't show full planning now. We just show how to plan this specific type of building here in the 3D. Maybe one more interesting thing, if you go to the climate data page again, normally if you start a new project, then you always will have the Berlin as climate data record and Germany at the location, but it's also possible that you can set your own start climate data record for every new project, because it could be really annoying if you always have to select South Africa or whatever, or Ghana, or and then for every single project. So it's good to set a default climate data record in your country, and this can be done here by using this small disk icon here. You select the record first, then you click on save climate data as standard, and then if every time if you start a new project, then this climate data record will be shown, and what makes it a little bit more easier. Okay, that is a small hint, and now we can go to the 3D part again. Click on edit. Again, we want to plan with the map section here. So of course, it's pretty similar to the planning before, but it's a little bit larger building with kind of sheds.
This case
to be a very common building type in Africa, because we also have seen it before, and I think as we planned in Ghana, there was some similar one. So Okay, we want to plan this one here. Yeah, and as you can see by selecting the different web providers, just for example, if you select Google here, if we select Google again,
Bing
then we
here,
can see then we can see the differences. Sometimes, especially for larger buildings, if you select Google, then it's often the case that it's a little bit from the side. You don't look from it just from above on the on the buildings, and this makes it sometimes hard to to find the buildings.
To draw the outline.
To draw the outlines. Right. So sometimes it's it's better to use the Bing, or another source, whatever. You have to switch a little bit and take a look what could be better. In this case, we would prefer the Bing view.
But here you can see what kind of building you have, where it seems like a row with different pitch roof, each above the other, or it could be also a flat roof with different sheds on it. Okay. And we would like to use Bing. And we have to zoom out a little bit. Okay, this is the maximum zoom factor here for the Bing map. We have to confirm.
But it doesn't matter because you can zoom in and afterwards anyway. And
we can zoom in.
The quality is not of the Google seller is not better than the Bing.
The other one. Okay, here we are. This is the building we would like to cover.
But of course, now we would have different options. You could use, as Thomas mentioned, it looks like there are different buildings with pitched roofs, so we could use different pitched roof buildings and then define it each by each, or we could use the full building here and add sheds to it, etc. So that are the options we have, and we have decided that we first draw the outlines of the whole building here for this.
Okay, then you have to press the escape button to interrupt the drawing mode, and now we can adjust it a little bit, but we also make it the right angle afterwards. I think we can start. It looks good. Oh, it's okay.
But you can also see the larger the building, the larger the uncertainties. So you have to keep this also in mind if you plan with this map tool. Then you have to keep in mind that there are some uncertainties, and they can be the larger the building, they can be really large. So it would always be good to probably
know the dimensions,
to know at least one dimension,
Okay. Now it's close to a rectangular. We make it the right angle. And afterwards we have to do a right mouse click to extrude the building. In our case, it's a building with flat roof. And the height of the eave should be 3.8 meters. Then we have to confirm it's okay. Then we can activate the building. And as Sixten has mentioned, now we would like to define one of these sheds, and then we would like to multiply this, to cover the entire flat roof. And therefore, again,
so you can also use this polygon tool on a building.
Yes.
Not just to draw the buildings on the map. So also if you have some texture on a building, you can just activate the building and also use the polygon for it.
Yes, for substructures, for shading objects or bad areas, and also if you would like to add a further building or 3D object on top of the roof. Therefore, again, we have to click here on Sketch a 3D polygon. Go to the lower left corner here. But now we have to, oh, it's up to here. So the lower part again. Escape. Now we have to make it the right angle. Now maybe it's 8.2. It looks like 8.2. Okay, so we have 8.4. It's not that nice. Okay, 8.4. It's close to 8.4. Yes, I think it's good. Now I have to make it rectangular, and then again we would like to extrude it. And it's not a skylight. We would like to use an arbitrary 3D object or roof. No, arbitrary building. We would like to have an arbitrary building. And the advantage of an arbitrary building is that we can edit it. Yeah, the height of the eave should be 0.0 because it's flat. But in case of an arbitrary building, it's possible if you click on Edit to define the reference edges and to which direction the inclination should be. And this is the reason because we have selected an arbitrary 3D object. In our case, it's in direction to reference edge number 2. It's still number 2, and the inclination of our shed here or building should be 20 degrees. Yeah, I think that's it. We have to close. Yeah, then we can activate it and can cover it with modules. We have to change to module coverage, and this is here the icon for selecting new modules. And again, we would like to use our favorites, the LG module. To confirm is okay. Also in this case, we select the option, or take the option fill area. These are the differences, the distances between the modules in horizontal and vertical direction. And these are the different installation type we have for choice. If it's roof integrated, without or with ventilation, if it's a flush mount, roof pallet installation, or do we have a module mounting on an open space roof or floating PV? And it's a flush mount installation with good rear ventilation. Okay, and now we can draw a frame, and only this frame will be covered with modules. We have 3 rows. Confirm is okay, that your modules will be placed. And yeah, that's it for shed number 2. Now we go back to our building number 1. And this is one shed here now, or one substructure on our building number 1. And now we would like to multiply this. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of these substructures. And first I have to go to Object View and then do a right mouse click, multiply object. And yeah, here we can define a small matrix with the number of objects in the right direction or in the upward direction. And yeah, here is a small wall between of these substructures. And yeah, now we would like to define the first steps is the eight substructures here on the left-hand side, and on the second step the other ones. That means that we have only one building here to the right and 8 upwards. And now we have to enter here a small distance, or we can do generating here our building to look how it looks. Okay, well, looks not bad, so we can use it.
So now So if you have the same structures, then it's good if you so you can just multiply it. You don't have to draw it each by each. Of course, as you can see, we tricked a little bit. They are not completely the same here, of course, as you can see it here on the right-hand side of the building. For example, there are some structures here, which normally you have to take into account. But yeah, we do it a little bit more easy then, of course. Yeah, if we define every single one, it's probably too boring for you. But yeah, in principle, you could remove one or and then make the bows here separately if you like. Anyway, so now we introduce our wall here. We are selecting here this wall object here, so you can place also objects on a building. Then you do a right mouse click, so drag and drop, right mouse click, edit, and then we can enter the width and probably the height or whatever. Okay, so we move it to the lower left edge here of our building, and right click. I think the height should be.
That's around 69 meters, and the height was 3 meters, I think.
3 meters, right? Yeah.
3 meters. Okay.
Yeah, close. Okay, now we have our wall. Then we copy one of the existing sheds here and place it here on the other edge here on the other side of the building, and then we again multiply it. And that's how it works. That's how you can create similar buildings very easy, fast, I would say, without creating every single building or single object in this case. But as you can see, there are some. So you have to keep in mind, as I told you, the uncertainties. And in this case, it's probably 1 to 1.5 meters, I would say.
Mm-hmm.
Okay, I think that's it for that one. So the rest would be the same. You configure it, etc., etc., etc. I think we can go back to the main window and finally say a few words to the database. So normally the database or the products in the database are entered by the manufacturers itself. So we have an online database where they have access to, and then they enter their products, and we perform a database update, which takes place about every 2 weeks. The last one was this morning, and there's a large amount of products, of course, in the database, but in some cases, the products you will find the products in the database. So then you have the possibility to enter it yourself, of course. So if you go to database and you select modules or inverters, you can use inverters, for example.
Inverters, okay.
Doesn't matter. Well, it's okay. So you can also change here to inverters, for example, and to create a new one, is you can create it from scratch just by clicking on new, or you can, if you have a similar inverter, for example, then you can copy the existing one here. Just select the one which is similar to the one before. Sometimes it's a series and one is missing from the inverters or the modules, and in most of the cases they have the same efficiencies. Then it's good to use an existing one. So as you can see here, the efficiency, because if you have an inverters, then it's sometimes hard to find the efficiency curve on the data sheet, which is, it's not very often the case that you find these values. For example, it's a little bit more easier for the PV modules, but anyway. Okay, so you can copy it, then you go to the basic data, and then you can enter a different name here at the description, and then of course you have to enter all the values that you can find on a data sheet here. For example, minimum output, input. I think this is an error. If you saw DC nominal input should be
Okay.
okay. So I have to note this. Okay, we found the bug. Okay, so you have to enter all these values that are needed from the data sheet. Just fill it in, and afterwards you can save it as a new record, and then can just use it like the ones which are in the database and people which were in the database before, which were delivered from outside. And this can be done for all the components which we have, like PV modules, batteries, battery systems, etc. So if you don't find the component you want to use, and you want to use it right now, then you can enter it yourself, for example, just by using the data sheet. Okay, I think so. That's it. That are the things that we wanted to show you. I hope you enjoyed it. If you need some more information about our program, please take a look at our website, www.valentin-software.com. If you have some questions afterwards, sometimes they appear some hours later or some days. If you work in the program, then please write us an email to webinar@valentin-software.com. Also, if you have some remarks, it would be nice if you send us a message. And I think that's it from our side. Thank you that you have participated here, and I hope you have we learned something, or we could showed you some new things. And that's it from my side. Take care. Bye-bye.
Yeah, also from my side, thank you for your attention, and maybe see you soon. Goodbye.